Hello, and welcome to CMPT 361, Introduction to Visual Computing. Visual computing is the field of computer science that deals with visual data and imagery. Visual computing is composed of two main subfields, computer vision and computer graphics, and in this course we will cover the fundamentals from the perspectives of both of these fields. My name is Yağız Aksoy, and I lead the Computational Photography Lab at SFU. My research, computational photography, aims to understand the world from a single photograph using computer vision techniques so that we can generate novel, realistic photographs using computer graphics techniques.
And I'm Jason Peng, and I'll be your instructor for the computer graphics component of the course. My research focuses on computer animation and robotics, where we try to build control models that allow virtual characters and real robots to move like humans and other animals.
We will start the semester with a computer vision perspective and first cover the image processing fundamentals. Then we will move on to image analysis, image registration, and image formation.
In the second part of the course, we'll be covering topics in computer graphics. Some of the topics that we'll be covering will include rendering, geometry modeling, and computer animation.
When working with visual data, we build mathematical models of the problem that we are dealing with. So, visual computing is a field under applied math. We use a lot of fundamental linear algebra skills throughout the course to build our models. To catch up on the required linear algebra fundamentals for this course, please, as soon as possible, watch the Introduction to Linear Algebra playlist that we share in the course website. This course is composed of two fundamental parts. The first one is the video lectures, and the second one is the in-person lectures. Video lectures cover the entire course content from start to finish. In the in-person lectures, we will further go into details of the mathematical fundamentals and extend our discussions in visual computing. Each in-person lecture will have an associated video lecture. You need to watch the corresponding video lecture before coming to the in-person lecture. When you are watching these video lectures, you should treat them as if you are watching a real lecture. You should watch these lectures while taking notes with possibly timestamps, and you should discover the additional material that we point to in these lectures. These notes will help you start follow-up discussions in our in-person lectures, and they will be very helpful as you are studying for the midterm and the final exams. You should also rewatch these videos, perhaps in 1.5 speed, as you are studying for your exams. In the first half of the computer vision videos, you will see that we discuss many things in MATLAB. You can use your own images and open up MATLAB to follow along with the lecture.
For the in-person lectures, we will assume that you have watched the video lectures beforehand, and we'll use the in-person lectures to go over any questions that you might have, as well as to go deeper into some of the topics. The in-person lectures will be held at the regularly scheduled class hours, but we will also offer full online support for these lectures. The lectures will also be streamed via Zoom, so feel free to watch the lectures online if that is more convenient for you. You can also submit any questions that you have in writing via the Zoom chat, and the lectures will be recorded and posted on courses. Due to the pandemic, please wear a mask when you attend the in-person lectures. And if you're sick, please don't go to class and instead watch the lectures online. If you have contracted COVID, please don't attend the in-person lectures for at least 2 weeks. Courses will be the primary platform that we'll be using for course activities. All announcements will be posted on courses. All of the assignments will also be submitted via courses. There will also be a discussion forum where you can post any questions that you might have about the course, and you can also feel free to send private messages to any of the instructors. There will be one midterm exam and one final exam in this course. The midterm exam will be a take-home exam, while the final exam will be an in-person exam. The midterm will cover all of the computer vision materials, and the exam will be held at the end of the computer vision component of this course. The final exam will focus mainly on computer graphics topics, but about a third of the questions will come from the computer vision component of the course.
We will have 4 assignments in this course. Two of these assignments will be in the computer vision part and two of them will be in the computer graphics part. You will have 4 late days in total that you can use for any of these assignments throughout the semester without any penalty to your assignment grade. We will also discuss these assignments in detail in the in-person lectures, and you can also come with your questions about the assignments as well in the in-person lectures. We hope you enjoy the course.
And feel free to reach out to us on courses with any questions or feedback that you might have over the course of the semester.
See you in the lectures.